good morning or good afternoon, depends, and welcome to my talk on medical malware on Android. I suggest we start this talk with a simple question that you ask to somebody who's not into technology. I don't know, a family member, a neighbor, or I don't know, the random person in the street, right? And the question is extremely simple. Are there viruses on smartphones? And listen to the answer. If you are in the same situation as I have been all these times, people are not aware at all that there are malware on smartphones. They know that there are malware on computers, but they don't know that they don't make the parallel with a smartphone and understand that they can also have some on smartphones. The reality we know is far different. I think it's good to remind you of the current figures. We have 6.1 million of malicious Android samples up to May 2020, and incoming every day 22,000 new malicious samples per day. Okay, so really an enormous rate of incoming malicious samples there. So now we have a second quiz, and this time the question is for you. Are there mobile malware abusing of medical situations? And you've got 4 different types of answers, ranging from no, apart pranks, to I heard of a few for COVID-19. Cyber criminals attacked numerous hospitals, and also, oh, I heard of a hacker remotely attacking a pacemaker. So think a little bit about which answer would suit you best, or what you would have answered to this question, or whatever, even if it's point number 5, right? And I'm going to give some of the answers there. The first one, well, there are none. Well, this is obviously wrong. Anyway, this is a talk about medical malware. So if there are none, it's end of the talk, right? Okay, you could have guessed that one. You heard of some related to COVID-19. Well, this is true. Well done. There are some mobile malware related to COVID-19. Nothing before this is wrong. But I'll discuss that a little bit later. Cyber criminals attacking numerous hospitals. It is true, but not related to smartphones. It's not a mobile malware attack. Okay. And finally, the one on the pacemaker, well, this is wrong. Actually, this is fiction. Okay, it was part of an episode of a TV series called Homeland, but it never existed. It's just pure fiction, right? Now, let me give you a short status about medical mobile malware. We became aware there were some only in 2019 and talked about that at Virus Built-in. A fellow researcher, Lucas Stefanko, maintains a very nice list of Android malware related to COVID-19. It is there, let me show you. There it is. And you've got lots of information, including very new one, where to find the sample if you want to analyze them, a few screenshots, links to the appropriate write-ups and things like that. It's a valuable resource, I think, if you're interested into that. Actually, malware abusing medical situations are not new to COVID-19, and we've had mobile malware in the medical sector for long. We brought this to attention while we were conducting some research on a connected glucose sensor for people with diabetes. And by the way, we will be giving a talk about that at Pass the Salt. It's a virtual conference too, like SecSea, a very nice one. And check the website, it is there, 2020.passthesalt.org. And you've got plenty of talks, of course, and if you're interested, well, please don't miss it, of course. Well, it's the end of this shameless advertisement, sorry for that. So actually, while we were doing this research, well, we found several malicious apps targeting diabetic patients. We found a few, then we found more, we blogged about it, and in the end I released a report now for SecSea. The report about mobile malware abusing diabetic patients can be found at this place here. This is the direct link. Otherwise, you go to FortiGuard's website, you go here in the research tab, then research center, and there you will have, at the time you go and look at, you will have a new entry for SecSea, and you can click on that and you'll have all the resources for this conference, which will be available at this link. But now, for now, this is the report. So it is just a collection of interesting, let's say, malware, which are abusing situations, applications that diabetic patients might be using. So we've got here a table: treatment for diabetes app, life expectancy app, insulin unit app, and how they are detected and what they are doing. And so this one is sending an SMS, like it's nearly a Trojan dialer. You've got, of course, also fake applications, lots of adware, and then you've got some detailed information for each of them, with a few screenshots, and also with code and how I reverse them, and the interesting parts of the reversing of those applications. For example, on this one we see that it is sending an SMS and it is checking that it has the right permission to do that, so it has the send SMS permission. We also see later on that if it has this permission, it will indeed send the SMS. So this is the obfuscated code. It's not too deeply and too difficult to deobfuscate because it's just strange names, but it's not more difficult than that. I have deobfuscated code here. There it is. This is the deobfuscated code that I kind of recovered. And you see it is sending SMS to 5554, for instance, and things like that. I think that, well, if you're interested into looking at, do have a look and read at this report. It's quite astonishing, actually, that for any kind of, it seems that for any kind of disease or medical problems, well, you'll have the malware that go with it. And I hadn't really expected as much as that, but for diabetes, you can find really tons of shady apps out there which are abusing of the situation one way or another. Now, when I submitted this talk to SecSea, my intent was actually to take one of those applications there and to reverse it in front of you, so that you see both how I reverse it and, well, the interesting part also is that it is a medical application, or, well, a malware abusing of a medical situation. But now that we've had all this COVID-19 around us, I think that you will probably be more interested by me reversing a COVID-19 application. The malware I chose to reverse in front of you is this one. It's really an interesting one. It was out only at the beginning of May the 1st. And, well, it's a new version, again, of that Anubis mobile malware, also known as, you've got a Nautilus bot, a banking bot, bank bot, got several different names out of it. It also is interesting to note that, well, there are some versions of it which really target specifically France, so, well, maybe a little bit more interesting to people in SecSea, of course. So I'm going to reverse this sample in front of you. So it's this one. You've got the SHA-256 for it, and this is Jeb. Jeb decompiler, but you can use actually any tool that you like to do that. The first thing that we notice, of course, is over here. Wow, very long names, crappy names, probably some obfuscation around that. It is really extremely typical of malware, so it's not extremely surprising. We go to the manifest, and in the manifest we're I like personally to have a look where the main is, right? And the main, you can spot it when you see the keywords main and launcher, and you see that then the name of the main is this one. So of course it's meaningless and it's awful, but we are going to look for that. So here in the bytecode hierarchy, here the easiest way is to type in my MVBO to try and find it, and you don't find it. What does that mean? Well, if we have a look, we see that actually this one is starting by Go, not by JRX. We don't have the namespace for that main class in the byte hierarchy. UK, Y, and we've got everything there, but it's not the right one. This is extremely typical of packed malware. So probably we have something which is packed, it unpacks the malware, and then once it is unpacked, we will have this correct namespace there, and we can go and have a look at the main and see what is really happening. But the first step is to unpack. So at this point of the analysis, what I like to do is fire up my tool, which is called Droidless, to give me some ideas of where to start the reversing. So I'll provide the sample as input and an output directory. That will be fine. And there we go. It starts unzipping it, disassembling it, decompiling, and after that it will give me some kind of summary on the malware and things which are interesting or not. So, well, we see plenty of things, the name there, the activities, and you see the names are really crappy, right? The main activity, it is here, we know that, the permissions which are required, receivers, services, and then actually some more interesting stuff, and this is what really interests me. We know we have an unpacker, and we spot Dex class loader, which is an Android class which is made to load some Dalvik executables. So it is using that, and this is probably the point, or at least one point, where it is loading something to unpack the executable. So it's gonna be some place I want to start with. So where is that used? Well, now I have a directory which has been populated for that sample, and I can go to my auto analysis file and look for Dex class loader. I could have done a grep, but it's not going to be very difficult. There it is here. So we're gonna have to look for a file, a class which is named nCoffeeTop, and this one is using Dex class loader. So we go back to Jeb and we're gonna look for nCoffeeTop, and there we go, nCoffeeTop. Nice name, right? And there it is. I am going to ask the class to be decompiled. And there it is. Now we're going to look for Dex class loader inside that. And we find it over here. So what is happening here? Well, we see that text class loader is being instantiated, and that's the text class loader. We can rename that. It's always useful for to understand the code better afterwards. If we go and have a look at the documentation online for Android, we know that text class loader, the first argument is actually the path of the file to load. So this is going to be the path of the text. I'm going to call this text path. And if we want to see something which is packed or unpacked, well, we have to find where that is. Right, so we're going to follow this text path up until we find where it is assigned to values and things like that. So who is calling squeeze defy? I press X and I find the cross references and we go there. And here it is, and we know again so that the first argument is the text path. So I'm going to rename it. And this time it's called inform symbol. We go up this one. That's the second argument we are interested into tracking. X, I go to cross references. Second argument is the text path. Let's have a look a little bit up there if we see that being used elsewhere. Well, it's the first argument of method only. Okay. X cross references, I go to the caller. First argument is text path. Slow engage, we go to the caller. I forgot. Yes, it's the first argument, so sorry, I go back again. Rename that text path. So where is that? It is here, here. Okay, and that method called attach base context. So it is probably created by Dream Drill v12. This is at least where we have the variable being assigned. So we're gonna follow what is inside Dream Drill and what it is doing and how it is constructing this text path. We get in there, and so what we're interested in is in what it returns. We notice it's a very small method, and the first line, well, it's junk code. This is junk code. It's assigning a variable which is never used afterwards. It's not supplied, there's nothing used from the supplied arguments, so honestly this is not used. Okay, so we go into slow unusual. Slow unusual, same thing. This is not used because what we return is only that hotkey recipe get absolute path, so probably hotkey recipe is creating a file, the file class of Java, right? And then we call get absolute path on that to get the absolute path of the file, right? So let's have a look at hotkey recipe. Hotkey recipe, again, this is junk code, very nice junk code, and this is the creation of the file. So actually this is probably the file name, this can be the directory or something like that, or part of the file name, and this is the file name. So let's have a look at that. Okay, we go up here, and oh, it is instantiated and initialized here. And let's have a look. So it calls pioneer what with a no full argument, number of trailing zeros, integer reverse math exponent to get parse int, trim enter. That's awful. Now my hint here is that actually probably the argument of pioneer what is not used, because what sense would the file name make if it was made randomly out of, well, maybe not randomly, but at least out of a mathematical construction? It would be difficult probably for the malware itself to find again the name of that random file name. So it's just a hint for now, we'll confirm that. Pioneer what? And this is the argument with the awful lot of construction and mathematical construction. And what do we see? When we click on that, it automatically highlights v9, and v9 is not used. So my hint is correct. So it is constructing a string out of that. So we're interested in what pioneer what returns for string there, which will probably be the file name of our text executable. There is an algorithm over here, and then the return, which is here, O cannot gaze voice saying. So we've got to go and have a look at what this is doing. Okay, so this, this v2 is junk code, and it is calling that. We get into that. Armor force. Okay, so the v2 again is junk code. We can actually write that. Sometimes it's easier to remember. Detail winner. And detail winner, oh, we see that this method is only returning the last argument. Okay, so actually it doesn't care about the first two, those are junk. We can rename that. Junk 1, junk 2, and return string. That's what we actually return. And we're going to rename that one return last argument. Okay, and we go back. So it's only this string that we are interested in. Armor force, only that string we are interested in. Voicing, same, it's only the last we are actually interested in. V1, so V1 is actually the string that we are returning. I'm going to rename that return string. And then it's interesting, indeed, we see there is some XOR construction over there, and it is applied on V0 and V3, which are both, V0 is a static array, and V3 is a smaller static array. So with an XOR, probably this is the key, and this is the encoded file name. And what is the rest? So then v51 is just an index, and you see that it is incrementing over here. So we have a loop going over the length of what we want to return. So it's a string of 7 characters. This is junk. Junk. Sorry. This is junk as well. This is useful. This is junk. This is awful junk again, and this is junk. Okay, so this is only what we need. So we're gonna use this piece of code and use it to decompile. So I'm gonna create a standalone Java code, public class. I'm gonna call that the code file. File name, that's the name. We need that. This is junk, this is junk, this is junk, this is junk, this is junk. We remove junk code. It's always easier, you know, honestly, just to remove junk code and see there. And we are going to return the string, and we create a main public static void main string args. Well, actually we have no arguments, so I shouldn't care, but well, we're going to call that system out dot println decode text file name, hopefully. And so we call pioneer what, and we give an argument. We know that we don't care about the arguments. There it is, and close the decode file there. So we now have our file, decode file in there. We are going to compile it, decode file. It compiles, then we run it. And there we go, and we get the name pa.json. That's interesting, so let's go and have a look in the unzipped malware, and we're going to look for something named like that. Sorry, pa.json. And it is an asset. So the assets file is here. There's plenty of stuff, but it's that file there, pa.json. It tells us it's data. And actually we see it's probably encrypted data. So this is at this point the encrypted text. Why is it in the encrypted text? Because we don't have the text magic file here at the beginning. When you have a look at a normal text file, there we go, hex dump, for instance, classes.text, and you get the text magic text 035 for the version, and we don't have that. Okay, so we know it's a bunch of data at this point, but we don't exactly know what it is. Probably something encrypted that the malware is decrypting afterwards. So now at this point, well, we can go back here. Let's go a little bit up, back to our text path. We know that this is pa.json, which is cool. Well, we can track text path and see where it is modified. It might be in here, it might be in here. This is one option, but it's gonna be long. At this point, we can try and be lucky, right? So we're gonna launch the malware in an emulator and see what is happening, and if we can somehow recover the unpacked part of the text. So we are going to launch an emulator. So I'm going to use one from the Android Studio, bin studio.sh. There we go. I get the welcome screen on here, and there I go in the AVD manager, and I'm going to launch this emulator, Android 8. There we go, it is here. So now I need to install the malware on it. We go back here, we have our sample which is there, but we need the extension APK to install it on an emulator. So I'm going to copy that, rename it bankbot.apk, and I'm going to ask to install bankbot.apk on the emulator. Success. You can see it here, right? I hope this is big enough. vAlert COVID-19 is actually the application. We're not going to launch it immediately. We will rather drop in a shell. We can list packages over here, and well, we should be able to recognize the name of our package pretty easily because it's so crappy. It's this one. When an app installs, it installs in the data directory, and then its name, application name over there, and we have that cache code. Okay, so nothing really good. It's an emulator. We can just try and click there. You've got to be sure that you have got well, maybe a firewall, things like that behind you, of course, and of course don't do that on a real smartphone. Okay, it is malware. And let's have a good look again at what we have here, and it's quite interesting. We are going to have a look at what we have in app dynamic lib. No, nothing in there. Sorry, this is crappy stuff. Then we go in dynamic Cryptax, and that's quite interesting. We have a pa.json here. We should have a look at that one. pa.json. It is again still data, which is kind of interesting. We're going to exit, and we're gonna grab the file. So adb pool, Cryptax pa.json, and I put it in this directory, and we're going to have a look at this file. And there it is. It's a dex actually. And if I do ph.json, it tells me it's a dex. It hadn't told me it was a dex because probably it hadn't finished unpacking. If I go back to the directory, it's app dynamic opt dex ls via pa.json. It still says data. That's interesting. Okay, I hadn't ever noticed, but the file on the Android emulator isn't that good, and it doesn't notice that pa.json isn't just data. It is a Dalvik executable. Interesting. So we're gonna analyze pa.json, which is the DEX executable, and load it into Jeb. I need to make it available in the right directory, so I'm gonna copy it here. There we go. And we launch it in there. And you're gonna see something is not working really correctly. We don't see anything, and if I ask to decompile this, it tells you processing of unit pa.json was attempted and failed. Would you like to try again? Well, no, it's useless. I don't actually like very much this feature, but the problem is just with the extension. It thinks it's a JSON, and it wants to analyze it as a JSON, but it's not a JSON, it's a DEX file, right? So I'm gonna rename it JSON.dex, and you're gonna see that it makes things far easier for Jeb. This, in my humble opinion, is close to a bug, and maybe it will be fixed by the time you get another release. And there we go. We get all our unpacked malware over there. Now let's remember what was the name of the main. It was myvigo, I think. myvibo. There it is. We can go in there. We decompile it. The uncreate method is a nice one to get into because it's the first methods which are called when you launch an application. And there we go, and it's absolutely readable. We see that it is launching a web view over here, loading a URL which has some JavaScript in it. So this is a JavaScript web page showing this, starting a service. This here is hiding the icon of the application, hide application icon, and setting a few alarms. So we're gonna have a look at the most important part, which has probably the most of the code of the malware, which is in this service. The name of the class of the service which is being started is that, okay? So we click on that, and well, it's an intent service we see, which is something that looks like a little bit like a service, but it has to implement onHandle intent. So we're gonna decompile and jump to onHandle intent. This is an intent, and we see that it honestly looks like a log line, but when we click on that, well, we see it's really nothing. It just gets a class. So probably it got obfuscated at some point, or just it's unuseful. So I just call it fake unuseful log. Okay. And then we see here it is using the Power Manager wake lock, new wake lock. This is quite common in malware, using that to ensure that the smartphone is still operational and running. If we have a look at the command new wake lock, well, it creates a new wake lock with a specified level and flags. The first one is the flag, and partial wake lock is the one, and it ensures that the CPU is running. The screen and keyboard backlight will allow to go off. So it probably kind of helps it be stealthy in there. So, okay, let's say CPU runs, screen can go black. Okay, just to keep that in mind. And here. So this is the context. We are here reading a shared preferences file, which is the kind of privileged way for Android applications to store their data, configuration data. This is a pointer to the editor of that file. And basically what we see is that it's going to retrieve a given item, the value for a given item, and provide it back. And if it is a specific item, URL, ing, or URLs, then it will go in here. And in here, this one doesn't do very much, but in here, we see there is a fixed hard-coded string over here, and this is our string. And basically we see, so it is decoding, base 64 decoding the string, and then this is just standard byte to char conversions. So this is probably the key, okay? And we see it is decrypting it. So here this is the initialization, and there we have, well, what we want to decrypt. So this is the base 64 decoded encrypted value, and it gets decrypted with this, which is the algorithm. Okay, we won't go too much inside that one. It's not extremely difficult though. So decrypt buffer. Okay, so this is base 64 decode and decrypt. You can really choose whatever name you want, of course. I am just choosing something that will be helpful for us to understand what the code does. Base 64 and decrypt. You can't choose exactly the same name. And there we go. So this is reading a preference item. We go and we jump back to the initial part there. So we are reading an item which is called SW packet, so software, probably software packet, software S packet, let's call it that way. Then there's logs, things which happen which don't seem to be very interesting. Here we've got an interval. Here we have time work. This is the device policy manager. Device policy manager. If the T-guard is in restricted input mode or not, Google stay. And here we have the URL. So if we have lots of URLs, we will go to this label which is in there. Okay, let's go jump a little bit to that part. And then we've got plenty of tests. I won't be having a look at everything in there, but it starts another service, and the service has this name, very ugly name again. We can click and have a look. It's again an intent service, so I jumped to the code hierarchy. There it is, and I have a look at onHandle intent to see what it is doing. So this is the start request, and it is reading various parts, starting another service. We can have a look quickly. It's gonna toast a string, which will be read from string accessibility stuff, and v3 is gonna be, well, the title of the application, basically. Okay, so it's gonna toast that. Let's go back a little bit. So it's the difficulty at starting, of course. A new reversing is at first you get plenty of things you want to go and have a look at, and you tend to get a little bit lost in your code, of course. This sounds like interesting, and it's not a play on word, right? Start records down a sound, and if this is stop, well, we'll be going there. And then up there, crypt file. Oh, is that like a ransomware and encrypting files on the disk? It could be, okay? It could very, very well be. So if it is not true, it will go to that label. So it means that we will be going here first. So let's have a look at this intent, kcdbt. So we are in KCDBT activity. We're going to head for the onCreate method there, which is always like the important part for activities. And well, we see the typical locking screen, and it's gonna request bitcoins to unlock everything in there. So this here, it's not actually doing encryption. It is just like displaying a URL, which is provided in the configuration by the HTML locker item. So this is the URL, and this is the amount that the victim will have to pay, and I don't know what that is. V1, maybe it's the Bitcoin address or the Bitcoin the currency of the cryptocurrency which needs to be used. Okay, we need to have a look at the exact JavaScript template here. So let's go back to here. So this displays Bitcoin JavaScript page. And here we see, well, start record sound. Okay, so if it is stop, we're going to jump here, but if it's not, we are going to continue. This is the number of seconds we will probably be recording sounds for, and probably this is going to be something about recording sound. Okay, so we can click on that one, and yes, it looks very much like that. So we'll call this one, this intent, like record sound. It will be far more understandable. I jump here to the code hierarchy, which corresponds, and again we go to onHandle intent. OnHandle intents, the intent is here. And well, in here we see that it is creating a .amr file name which is based on record sound underscore and the date. So we'll call this one file name. This is going to be the external files here on the SD card. So anyway, this is going to be the absolute path for the file name. Absolute path file name. And then what happens is, this is how long probably we are going to listen for, and this is probably where things get done. So let's go in here. We have here the context. So this is the context, absolute file name, apps file name, duration. We're going to log sounds, and media recorder is here, media recorder. And we are going to record audio for a given time. This is starting a thread. It will log, and it will also, as you can see, that's strange, it's gonna base, oh yes, sorry. I was thinking strange that it is decrypting stuff, but not encrypting stuff, but here it is decrypting some items in there. Okay, so if everything goes good, it will delete the file because it probably has copied it. So yeah, it will be running this thread for a given amount of milliseconds. This is probably seconds, and they're the milliseconds. We won't be going too much in detail in there, but well, the intent is is obvious. It's gonna record the sound and put it into a file. So record sound to file, for instance, and let's go back in here. There it is, and we are gonna jump back in there. Okay, so this was if we didn't have the start record sound set to stop. Well, then it would be like something start, and it would start there. Then we also have a lock screen preference in there. So if we have this is true when that is not there, so obviously if that class hasn't been started, then we are going to start it. And what is that going to be? Well, this is probably going to lock the screen, right? So I click on there, and it's another intent service. You know by heart what we do now. We go on unhandle in that intent, sorry, and we're gonna have a look at what that does, but very probably lock the screen one way or another. So this is just waiting for a given amount of time. It's starting another activity, which is here, reading again the preference lock screen pref, and that is about all. So probably we have to go in there and see what that is doing, and it's an activity. So activity, we have a look at the on crate. So this is the bundle. This is basically, you always have to have this. So it is creating a content view, and the content view has that. So it has a paint and a rectangle, I guess. And there we go. So this is the paint which is going to be used, and we're going to draw a rectangle. And when we draw, well, this is what we do. We are going to use this color. So the first one is alpha, then it's red, green, and blue. So this is actually black color. And we're going to draw a black rectangle on the screen. Okay, and well, if we press back, it should be working. If we destroy, it should be working. If we press a few keys down, we could have go and have a look at those key events. There's probably the home button, the back button, things like that. Well, it is doing something, but we'll move a little bit short. So what is happening? And how is this locking? Well, actually, what happens here is that it's going to start the activity where something is going to draw a black rectangle on the screen, which is going to be pretty annoying, right? And then we read the lock preference. If it's true, we get here, and we're gonna go to label 0. Label 0 is going to sleep again for 1 second. Okay, so we sleep, and then, well, we loop back. Okay, we're going again to draw that black rectangle and test if we still need to lock the screen or not, and then loop again, right? So this is actually implementing the screen locker. So this is their screen locker. There we got. So yeah, it's not actually lock screen, but lock screen. And well, there's some other things there about ignoring battery optimizations, probably to ensure that the malware keeps on running. It is testing to see if there is a file name crypt.apk. So this is something else. Okay, we're not going to get into that one. Play protect. It's some inner protection and mechanism that the malware is using there. And this is pretty much already what we can see from here. So if we want to dig a little bit more into the sample, well, usually for big samples like that, I run droidlysis to help me spot the most interesting parts I should be looking into. So I'm gonna run this on the unpack file pa.json, which is not a JSON again. Once again, it's a text file, and I'll run that. By the way, you will have, of course, the link of droidlysis in the slides or somewhere on the website on FortiGuard. It's on GitHub, so if you just try GitHub Cryptax droidlysis, you will find it, and you are just welcome, of course, to use it. So here it analyzes it, and well, what we see, for instance, is that it is sending SMS, receiving SMS. It's also opening sockets, which is pretty weird. Using base64 encoding, we saw that one. SSH also probably is a bit weird and would need to be investigated more. Cryptocurrency uses cryptocurrency. This is the reference to the web page, which is actually asking the victim for some bitcoins. So we'll just have a look at that send SMS part. So as I told you, we now go to the output directory and have a look at analysis, and we're gonna skip all of that, and there it is. Send multi-part text message is a way to send SMS messages on Android, and the class that calls that is that ugly name, which is here. So we're going to go back to Jeb and search for this class here and this package, sorry, here, and the subclass B. So RYQ something. Yes, we are inside there, and the class name B, it's this one. So in here, probably there is something sending SMS. And oh, we'll get back to that. It's interesting. It's sending, it's doing a connection to a Twitter account. Send multi-part, and there it is. Send multi-part text message. We can go and have a look here at that function, multi-part text message. On the Android documentation, and let's go and have a look at that method, multi-part. Oops, I shouldn't have clicked that one. Okay. Multi-part. There it is. Okay, so we see, I can make it perhaps a bit bigger there, that we have first argument is the destination address, then the source address, then the various parts for the SMS to be sent. So this is the destination number. The source, well, it's not being provided, and then you've got the parts. Okay, so this is send multi-SMS. And who is using that? Well, there's pretty lots of functions. We can have a look at that one. This one is sending, so the destination number is the second one. That's the destination number. And it is retrieved. Oh, it goes in the contacts. Okay, so it's probably sending SMS to your contacts to, of course, spam them and have better chances that they are going to install the malware also. That's very, very probable there. Destination, send, and arg9 is something else, whatever. Okay, so this one we can say send SMS to contacts. I'm gonna have a look at who is calling that one. And well, yeah, it will be triggered if we have this parameter and whatever activity. Okay. The other cases, well, we have this one as well, which is starting and sending SMS, and then this is when there is a message which is sent to this service. Well, it's going to send an SMS to that particular number which is provided in the intent and the message there. So this is probably rather the bot sending a specific SMS, wants to send a specific SMS to this or that number, and of course it will be at your charge. And that is pretty good. So remember, in that class which is sending the SMS, at the beginning I told you, oh look, there is a Twitter account, and indeed here it is connecting to that Twitter account, well, the URL. Okay, so this is a URL connection. It is reading the lines that it finds there, so that is read line, appending that, so we have all lines in here, and then it is removing spaces. This is getting a substring from there and retrieving only the important part, and then decoding base 64 and decrypting to recover the meaningful information there. So if we have a look at this URL, it is still up currently, but it might be down afterwards. Well, you have plenty of, you know, messages there. Maybe not all of them are related to our bot, but probably this this Twitter channel should be looked at very precisely, very closely. I also told you at some point that we were using SSH and sockets, so let's have a look at that as well. So we have a reference to SSH in here in that method, so it's in KUV, and then the class is SFS www. Okay, so I did that meanwhile, and I searched in that class SFS www for where we are using SSH, and we see that line over here, which is the reference to the SSL. So as not to lose too much time, I renamed a few variables at the beginning for better understanding. But basically we see that the malware is creating a server socket, and it is starting socks. Socks is basically going to help it use an SSH tunnel to secure the communication with the bot and the bot master. And there it is here. Okay, so here you've got the port number, the redirecting port number, username, host, and that's basically also an interesting feature that we can see in that malware. We don't see that one very often actually in malware as far as I have seen. So this is pretty much enough for this conference. There is still yet other things to see in the sample, and if you liked it, well, please go and see in the sample and continue by yourselves for the other remaining stuff. But you pretty much have found the most interesting parts and know how to do it. If we do a short recap, well, we had unpacked malware. We unpacked it, and in the unpacked DEX executable, we saw that it is able to record audio, and it will put the file with the recording on the SD card with an extension .amr and the file name containing the date. It also is able to lock your screen, okay, like well, a locker, right? It will put a black rectangle on the screen, and it will continue having it put back on your screen, and so it will be pretty much annoying and probably very difficult to use your smartphone after that. We saw also that it has the ability to push a web page on the smartphone, requesting you to unlock your smartphone by paying a given amount of bitcoins. Okay, so this is very classical to ransomware. Among the other things that we saw is that it can send SMS messages. It can either be on request from the bot master to send a specific whatever message to a given number, or it can also be to send some SMS messages to your contacts, presumably to propagate the malware. I am saying presumably, it's because we haven't exactly seen it during our reversing, but of course everything can be confirmed by reversing the sample. We also saw that, well, every data that it thinks is important gets encrypted. By encrypted, we mean that it decodes it with base 64 and then decrypts using its own algorithm. It's not anything which is cryptographically solid, but it's kind of achieves what it is meant to do. It obfuscates the screens and makes it more difficult to decrypt. And the key that it uses is Eric Cartman, and if I am correct, Eric Cartman is a character in South Park. We also saw that it is using an SSH tunnel for its own communication to secure it. So this is pretty much the end of this talk. I hope you enjoyed it. Thank you very much for listening. It is really more difficult for the speaker to be captivating and interesting in this virtual format, but I hope that way you have the time to follow perhaps with your laptop and do things just besides and try to do it yourself. On this last slide here you have plenty of links that I have been mentioning throughout the presentation. So, well, it's just so that you have them and you can use them, of course. And hopefully, I hope they will be helpful for you. So, well, thanks again. You have my contact details there. You can find me on Twitter. If you speak French, there is also a Discord channel I have created on research for malware in general, reverse engineering and things like that. So if this is interesting to you, feel free to join. That's what it is for. As for myself, as you might have guessed, well, my specific fields are the research around Android malware, but also IoT malware. Speaking of that, I am one of the organizers of Phone CTF, which is a Smart Object CTF. Check it out as well if you are interested. It usually takes place end of November or December. This year, 2020, is obviously really special for all conference and CTF organizers, so I can't tell you yet how it is going to take place, but we are working out very hard to get you something which is kind of interesting and attractive for this edition. Well, bye bye and take care, have fun, bye bye.